This is your exam review for Chapter 10 and 11. So we'll jump in with Chapter 10. If you need to pause the video at any point to write things down and catch up, please do. I already have the notes outlined, so I'm probably going to move a little bit faster. So again, utilize that pause button and we should be fine. I'm just going to go through the different examples. You can either pause now, write them down, and then just listen, or try to pause as you go. A radius is a line from the center to the edge of the circle. I highlighted it blue. It is line AB. The diameter is a full line across the circle. So for example, C to D goes through the center. A chord is a line that touches each edge of the circle and stops. So that's EB. Whereas a secant line goes through the circle. So it's the same thing as a chord, but it goes on forever. That's F to G. A tangent line touches the circle and continues on forever. And then a minor arc is less than 180. You can see I used CB. A major arc is more than 180. A central angle touches the center point. And an inscribed angle touches the edge of the circle. So those are just some key definitions that make this chapter go smoothly. So I'm going to jump through some examples. Again, chapter 10 has a ton of different examples. I can't get through all of them, but it should hopefully jog your memory. Highly recommend using your equation sheet to guide you. So the first few don't actually require the equation sheet. They're just kind of different properties we talked about up above. So this first one, we have a central angle right here of 60 degrees. And when you have a central angle, it's the same as the arc. So this arc from A to B is also 60 degrees. So central angles are the same as the arc. Now, inscribed angles right here are half of the arc. So I would take 60 and cut it in half, and that's 30 degrees. Example 2, in a quadrilateral inside of a circle, opposite angles add up to 180. Okay, so these two add up to 180, and so do the other one. So 180 minus 130, x would be 50 degrees. 180 minus 90, y would be 90 degrees. When you're asked to find the radius, it can look a lot of different ways, but it's really coming back to Pythagorean theorem. In this case, remember your C is the hypotenuse. So I'm going to go ahead, r squared plus 24 squared is equal to 25 squared. And I get r squared plus 24 squared, which is 576, is equal to 25 squared, 625. I'm going to subtract the 576. I get r squared is equal to 49 square root. And I get that r is equal to 7. Number 4 is from your equation sheet. It's when two lines intersect inside of a circle. And when that does happen, you take the pieces of the line and multiply them together and equal each other. So for example, I'm going to do 5 times 12 is equal to 3 times the other part, x plus 2. So 60 is equal to, if we distribute, 3x plus 6. I'm going to subtract 6. 54 is equal to 3x. Divide by 3. And I get that x is equal to 18. Number 5 is also on your equation sheet, and I don't exactly remember how I wrote it on there, but it's the measure of angle 1. Okay, this is angle 1 right here. is equal to half of the outside arc minus the inside arc. Okay, so outside is here, inside is here. And so I'm just going to plug this in and be able to solve it. So the measure of angle 1 is 32, is equal to 1/2 of 140 minus x. And we undo a half by multiplying both sides by 2. So 64 is equal to 140 minus x. I can subtract 140. And I get 76. Negative 76 is equal to negative x. And so x is equal to positive 76 degrees. Okay, I can't stress enough. These are only a few of many examples, but hopefully it jogs your memory. You need to do the practice to refresh, okay? The last part of chapter 10 was circle equations. And when we do circle equations, okay, we remember H and K are the center, and they're always the opposite, okay? And then R is the radius. So I have an equation where I'm going to write the equation. So this is my H and K, and this is R. So I would write x minus 4 squared plus y plus 2 squared. Again, those are always opposite, is equal to 3 squared, and 3 squared is 9. You do want it as simplified as possible. That looks good to me. Chapter 11. Okay, chapter 11, again, there's some important vocab I'm just going to quickly go through, but use your equation sheet. The vocab is driven on that equation sheet. The arc length, the circumference, area, all of those things, okay? The circumference is the distance around the circle. Okay, let me say that again. The circumference is the distance around the circle. Then we have the area of a circle, the arc length of a circle. The arc length of a circle is like a part of the outside. The arc measure is in degrees. Okay, that's super important. Arc measure is talking about the degrees. Area of a sector is, again, like a pizza slice. What's the area of a pizza slice? And then we did regular polygons. I went through and picked out some important examples. Again, I really think you should practice. There's not that many equations. It's just knowing how to use them and solve for the different pieces. So I'm going to do my best to go through them. And again, reach out if you have questions. Number 1, find the circumference of a circle with the radius of 12. Okay, I'm just going to draw us a picture here. Okay, I have a circle, and the radius is 12. Remember, the radius is from the center to an edge. Circumference equation is pi d or 2 pi r. Doesn't matter which one, but because I'm given the radius, I'm going to use 2 pi r. So the circumference is equal to 2 pi times 12. And it wants my answer in terms of pi, so I'm just going to write 24 pi feet, right? Circumference is just a distance, so it's feet. That would be my answer. Number 2, find the area of a circle with the diameter of 18. So, again, I'm going to draw us a picture here. I have a circle. The diameter is 18, which means the radius is 9. I always like to think ahead, like, what does that look like? The area equation is pi r squared. So I need to use the radius. So area equals pi times 9 squared. I'm going to go 81 pi centimeters squared. So this would be if it asks you to leave it in terms of pi. I could also round it to the nearest tenths for practice. I'm going to go 81 times pi. And you could go 254.5 centimeters squared. And again, it really just depends, like, how is the question asking for its answer. Now, those two equations drive the arc length and the area of a sector equation. So those are our next two examples. Okay, this first one is maybe a little bit more tricky. It says, find the arc measure. Okay, arc measure is degrees of a circle with the arc length 15.6 and the radius of 4. So again, I'm just going to like draw a quick picture. Might not be accurate, but we're going to try it. Okay, I have an arc length around the circle of 15.6. I mean, we don't really know how long it's supposed to look. And a radius of 4. So I'm asking, like, what is the angle for that? The key here is that it says arc length, and we need to use the arc length equation. So I'm just going to write that down. Arc length is equal to the measure of AB, so it's the measure of the arc over 360 times 2 pi r. So again, I'm finding the measure in degrees. I'm finding that, and I'm plugging everything else in. So watch how we do this. The arc length is 15.6. I don't know the angle over 360 times 2 pi 4. And again, you can put this over 1 if you want. We're going to multiply straight across, and then we're going to simplify. So 2 times 4, so I get 15.6 is equal to 8 pi x. That's the top, right? Multiplied across, all over 360 degrees. When I want to get rid of the denominator, I multiply both sides by 360 degrees. So these cancel, and I'm going to do 15.6 times 360, and I'm going to move this back up here. So I get 5,616 is equal to 8 pi x. And again, I'm trying to get x by itself, so I'm going to divide by 8 pi. And this was a mistake a few of us made. You need to group the denominator. So if I'm putting this in my calculator, I'm dividing it by the quantity of, in parentheses, 8 pi. And I get that the angle is 223.5 degrees. Okay, so my picture's not accurate, but I'm finding that angle measure. Okay, and again, the key is reading that it's talking about the arc length, so that's how I knew what equation to use. All right, number 4, find the area of a sector with an arc measure of 120. Okay, so I'm finding the area of a sector, okay, and again, that's like a pizza slice, so I'm going to go ahead and draw us a picture. Okay, 120 degrees is a little bit more than 90. And again, doesn't really matter how accurate your drawing is, but I'm finding this shaded area. And again, refer to that equation sheet so that we know what we're doing. So area of a sector, okay, is the measure of the arc over 360 times, now area, is pi r squared. So I'm using this equation to go ahead and solve. So I'm finding area of a sector. I know it's 120 over 360 times pi 7 squared. And so I'm going to simplify straight across. So 7 squared is 49. And 49 times 120 is 5,880. So the area is equal to 5,880 pi all over 360. And again, I'm going to just go ahead and plug this in. I'm going to round to the nearest tenths. So 5,880 times pi, and then divide that by 360 degrees. And the area of this piece is 51.3 inches squared. Okay, area is inches squared. Okay, the last example is finding the area of a regular pentagon. And I chose a pentagon. I think some of our common shapes are pentagon, hexagon, heptagon, 7 sides, and octagon, 8 sides. I would practice them all. Okay, they are repetitive, but I would do all the sides. Okay, but for this example, our side lengths are 6. Just a reminder of a regular polygon, area is equal to 1/2 the apothem times the perimeter. If you're given the side length, you know the perimeter, okay, because each side is 6. And so my perimeter is 6 times 5, which is 30. So I know my perimeter is 30. What I don't know anything about right now is the apothem. And my apothem, remember, goes straight down. So that's what I need to deal with right now. And we always start by going 360 degrees divided by the number of sides. So 360 divided by 5 is 72. And I need to cut that in half to get this little piece of the angle right there. So 72 divided by 2 is 36 degrees. So this angle is 36, and my apothem is right there. So I'm just going to redraw this triangle like we've done before. And I'm looking for the apothem. That's this highlighted green side. I know that this whole base is 6, so half is 3. And I don't care about the radius of this triangle, of the pentagon, which is the hypotenuse. And then I have 36 degrees. So when I go ahead and do this, this is opposite and adjacent, and that's tangent. So I'm going to go tangent of 36 degrees is equal to 3 over A. I need to get A out of the denominator, so I'm going to multiply both sides by A. And I get A times tangent of 36 is equal to 3. Divide by tangent of 36. And so 3 divided by tangent of 36 is our apothem. And so I'm going to go ahead and plug that in my calculator. 3 divided by tangent of 36. And I get that my apothem is 4.13. Okay, again, we said round to the hundredths until the end. So I know my apothem is 4.13. My perimeter is there, and so I can go ahead and solve. Area is equal to half of 4.13 times 30, and I'm going to go ahead and get my area. So 0.5 times 4.13 times 30. And I get an area of 61.95 feet squared. So again, that covers like the general idea of chapter 11. It was only 3 sections, so it's much shorter. Again, practice, do the exam review, and see how it goes.